Hello, welcome to this edition of the Henstitute. We're going to continue with Chapter 1. This would be the last little section of it. We're going to talk about components of vectors. And what I mean by that is we're going to be taking a vector and trying to break it apart into its pieces. So we're not going to actually treat it all as one complete vector. So sometimes when you have a vector, like we described earlier, we had this resultant vector for a car traveling. Let's say we have this 2 kilometers that was at 30.0 degrees north of east. Let's say we had that one. So this angle down here would be our 30.0 degrees. Sometimes it's nice to actually figure out what we call the components. In this case, X would be how far east they traveled, and Y over here would be how far north they traveled. So in other words, take this single vector, this one vector, and break it apart into the pieces that are in these cardinal directions, or maybe horizontal and vertical or something to that effect. It's going to be very useful for some of the stuff we'll do. The reason why we do this is these two vectors add together to give you this vector that you have. It's very similar in math class if you've talked about polar coordinates versus Cartesian coordinates. So if you notice, I'm using X and Y here because that's a common notation, and then here I have a single vector at a particular angle, which is very similar of talking about polar coordinates with a magnitude and an angle direction. So the idea is if you were to add these two vectors together, you would get your result of that. So that's what we want to be able to do. So let's grab an example. Let's say that I have a displacement vector that is 175 meters and it's at 50 degrees relative to the x-axis. So this might be north of east, or it may just be up from horizontal. So either one. I want to find these components. I want to try to figure out what X is. I want to try to figure out what Y is. Before, if you noticed, I used a lot of tangent. I used tangent when I was solving to find that resultant. Now I'm going to actually pick out the SO and CA of SOHCAHTOA to try to figure some stuff out. And the reason why is the sine of my angle here, this 50.0 degrees, would equal my opposite side. So the opposite side is this y. So it's the y vector over the hypotenuse vector, or the resultant vector. So this would be y, how far up or how far north they are, divided by 175 meters. So to figure out how far they went up, we would actually be taking the 175 meters and multiplying by the sine of 50 degrees. So we're not doing an inverse sine. We're not doing, just like before we were doing an inverse tangent because we were trying to find the angle. We know the angle. We're trying to actually find the length of the side. I can't actually do trig functions with my calculator on this board, so I'll just type this on my calculator, 175 times the sine of 50 degrees. Make sure I'm in degree mode. And so I find that they are going to travel about 134 meters up, north, whatever that direction happens to be. Then I'm going to actually borrow cosine for the other one, because CA will allow me to do this. The cosine of my 50 degrees should be my adjacent side, x over the r, and so my x over the 175 meters. Do the exact same idea. So x would equal the 175 times the cosine of 50 degrees. Again, and we're not using an inverse. We're using the actual cosine function. Since I have this, I'm just going to change this over to cosine and ka-chunk it, and I get this is 112.5 meters. Or 113, somewhere in there. So now I've found the components of this vector. Okay, why do I need to know that? Why would I want to try to find that out? Well, if I had a vector C here, for example, And it came because I was combining two other vectors. So I have vector A here that kind of goes diagonally like this, and then I have vector B here that goes diagonally like this. I can use this black, purple, red triangle, this ABC triangle, to find stuff, but it's not a right triangle, and it's not easy to try to find. It might be okay to find the hypotenuse, to find the length of this using things like the law of sines and the law of cosines, but to find the direction is very difficult. So it's actually much easier to take this vector A and break it up into how far they go in the x direction. How far does that go in the y direction? And then take your other vector here, vector B, figure out how far does it travel in the x direction, how far does it travel in the y direction. That'll get you to your finish up here from your start. And then technically what you're doing is you're just going to combine the x's together. So how far they went in the x direction for each one, and then do the same thing with the y's. Those are now a right triangle. You have a big right triangle we can work with. And so ax plus bx is basically cx. It's how far they go horizontally. And ay plus by is basically cy, and how far. And now we can actually find this. So let's try this out. So let's say I have vector A has a displacement of 5 meters at 30 degrees north of east, and then vector B is a displacement of 8 meters at 60 degrees north of east. What is the resultant vector C of the combination of these two vectors? The first step is I want to take these two vectors, vector A and vector B, and we often kind of designate with an arrow on top, and I'm going to break them up into their components. So I'm going to start off with A here. I'm going to try to find AX and AY. So just like I did before, X, if I go back, notice that x was using cosine and multiplied by the hypotenuse, and y was using sine multiplied by the hypotenuse. So I'm going to do the exact same thing. I'm going to take my hypotenuse, which is 5 meters, and to find the x, I'm going to use the cosine of this 30 degrees. And then for the y, I'm going to take my 5 meters and multiply by the sine of my 30 degrees. Here's an extra little trick. I happen to know the sine of 30 degrees is actually 1/2, so this would be 2.5 meters. And then the cosine of 30 is actually the square root of 3 over 2, but not quite as easy to figure things out. So this one comes out to be 4.33 meters. I'm not trying to do significant figures right now. I'm just writing down some numbers. Technically, I guess it'd be 4.33 and 2.50. Do the exact same thing with my v vector. So take this 8 meters at 60 degrees north of east and find bx and by. Or if you want to, I suppose this could be b to the east and b to the north. So just like this is 4.33 meters east and 2.5 meters north based off of my original directions. But I would do the exact same thing. I'm going to take my 8 meters, going to multiply by the cosine of 60 degrees, and then I'm going to take my 8 meters and multiply by the sine of 60 degrees. Cosine of 60 degrees happens to be 1/2, so I can find that one easy. This is going to be 4 meters in the east direction, and then the other one, the sine of 60 degrees, is going to be my square root of 3 over 2, but this gives me 6.93 meters. Okay, so all I did right now is I did what I did back here in example number 5, is I took that single vector and broke it up into its components. How do I get C now? So my ultimate goal with C is I'm going to combine those together. So I'm going to take how far did it go this direction. So in the x direction it went 4.33 meters. How far did B go in the x direction? It went 4 meters. So the total of those two in the x direction, in other words, what cx is the sum of those, because they're in the same direction. Hey, we had that in the first little thing, that they're in the same direction. You just get to add them. So this is going to be 8.33 meters east. Then I come over here and do the same thing with the y's. AY here was 2.50 meters. BY up here, trying to remember, was 6.93 meters. I can add those two together to try to figure out how far in the y direction I'm going to be. 6 and 2, so that's 6, 7, 8. So we got 9.43 meters in the north direction. Now we're going to go back to what we did on the first set, and we're going to try to combine them together to figure out what c is. So the c vector itself, the first step we have to do is find the length of this hypotenuse. So we're going to take the two sides, 8.33 squared plus our 9.43 squared is going to equal c squared. So that's going to be the hypotenuse squared. So I'm going to cross this out because I'm not finding this, but I'm using my a squared plus b squared equals c squared. So that'll allow me to figure out what c is. So pull out my handy dandy calculator here. 8.33 squared plus 9.43 squared. Square root that. So I get 12.58, or about 12.6 meters. So that's how far they travel. The next step is I need to figure out what this angle is down here. So going back to what we did on the other set of notes, we're going to use tangent. I'm going to take the inverse tangent of my opposite over my adjacent. So I'm going to take my 9.43 divided by my 8.33. So the inverse tangent of 9.43 divided by 8.33, and I get this to be 48.5 degrees. What is the direction? It's going to be north of my east line, because I'm starting here, I'm measuring north of it. So it's going to be north of east. And ta-da! I have found the magnitude and the direction of my c vector, combining them with components. Why couldn't I just come back to this triangle and use it? You could, and we could probably find the hypotenuse. Some of you know the rules with the law of sines and the law of cosines. I find it so hard to find a direction, because you really need this entire angle in respect to east, or you need this angle with respect to north, and it's so much easier to do it with components, so you can actually take what you want to do and figure out everything. So that has been this last edition of the Chapter 1 AP Physics 1 Honors Henstitute, and hope you enjoyed.